Good morning, my name is Sathiis Kumar. Today I am going to present assignment 2. In the assignment given, there is a circuit diagram consists of inverter, LCL filter, load and grid voltage. The inverter will convert the DC voltages into AC voltages. The output AC voltages will be consist of a lot of harmonics which cannot be conducted to the other parts of the circuit. So the LCL filter is introduced. The LCL filter will filter out the harmonics and give clean, pure, alternating current waveform to be connected to the other parts of the circuit. And there is a load. The load is used to measure the voltages and currents around the circuit. And there is also a grid voltage. The grid voltages can be connected with the circuit by turn on the STS switches. If the STS switches are turned on, it will be connected with the inverter circuit. If it is turned off, it not will be connected with the inverter circuit. The conduction of current in the circuit can be classified into two. They are in phase and out phase. If the condition is in phase, when the current flows from the inverter to the grid, which means when the STS switches are turned on and the current is flowing from the inverter to the LCL filter to the load and to the grid voltage. The second condition is the out phase. Out phase means when the current is flowing from the grid to the inverter, which means the STS switches is turned on. So the current is flowing from the gate voltage to the load to the filter and finally to the inverter. So the in phase and out phase has independently different formulas to find the I phase. So in order to find the I phase during the forward direction, the formula is VA prime, which is the input for the inverter minus with VA and divided with Z total, which is the total impedance. If the condition is out phase, the formula is VA minus with V prime, VA minus with VA prime, which is the inverter power supply, and divided with the total impedance. So in the in phase condition, the waveform will be when the voltages waveform is at the positive region, the current is also at its positive region. If the second condition is out phase, if the condition is at the out phase, when the voltages are positive, the current will be negative. The first condition is given as the power transfer of 2 kW from DC side to the 3-phase load AC side, and it is maintained transferring 2 kW power to the load even after the switch STS is connected to the grid voltage. In short, the current flow in the circuit diagram is in the in-phase condition, which means the current is flowing from DC to AC and the current flowing is 2 kilowatt. Since the STS switches is turned on and there is no current flow to the grid voltage, it means the current will be flowed 2 watt to the load and no current flowing to the grid voltage. The direction of the current flowing are from the DC voltage, inverter, load and the grid voltage. Before we get into the further calculation, we need to design our filter. Our filter is LCL filter. So there is 2L and 1C. The Z value, the ZB is 31.25. The CB is 1.019 decimilli. The CF is 5.095 micro. The Imax we obtain is 6.532 ampere. The delta Imax we obtain is 0.6532 ampere. The L1 value we obtain is 6.091 milli. The second L we obtain the value as 74.574 micro. For the WRS, we obtain 51.615 kilo. The F reference we obtain as 8.125 kilohertz, and the R reference we obtain 1.2680 ohm. From the calculation for the first condition, we may obtain the total impedance as 0.05 plus J 1.968, the C 1.969, the theta is 88.545, and the VA prime we obtain is 204.4566 plus J 12.8579. If we run the simulation, we may obtain the output. First, we see the grid voltage and current. So, as per the question states, there is no current flow in the grid even the STS switch is turned on. The straight line indicates condition where the STS switch is turned off, and there is a little current flow, which means after the STS switch is turned on, but it is never affect the output. So we can say that the current flow across the I grid is zero. Next, if we see the voltage and current across the load, we may notice that the power transfer 2 kW to the load once the switch is connected. Then, on the display at point C, which is the output power at the load, for this condition is almost 2 kW, but the output power as point D at the grid is actually is equal to 0 because there is no current flow to the grid, even though at the display it shows have current to grid, but actually it is almost to zero. When round off the current obtained across the D, it is equals to zero. The second condition states the power transfer from DC side to the AC load, which is the 2 kW until switch SDS is connected, where now the power transfer is happened from AC side to DC side, whereby 2 kW will goes to the three-phase load and another 2 kW back to the inverter, which means the circuit is operating in the reverse direction, which is the outphase. The current is flowing from the AC side towards the DC side. So, for the calculation part, for the total impedance we obtain is 1.969 88.545 degree. So the V peak we obtain is 204.13 volt. The VA prime we obtain is 203.8034 minus imaginary part 12.8579. So the C value is 203.3974, and the theta we obtain is negative 3.61. If it is combined with the C value, we obtain 203.3974, and the degree is negative 3.61. The n value we obtain is 0.8.36, and the delta is negative 3.61. From the simulation, we can notice that the voltage at the point A, B, C, and D are same, and there is no power losses. From the simulation, if we notice the V out versus the VD graph, it is proven that the current flowing in the circuit is in the reverse direction, which is the outphase. It is shown where the voltage is at the positive region and the current is flowing from the negative region. If we notice the current and voltage across the load, it is shown that the three phase delayed by 100 degrees to each other, and the output drop because of the switch, and the increase in the graph is caused by the power flowing in. So when the switch is connected to the power that may transfer to the load is 2 kW, and the another 2 kW is to the inverter, which is the inverse reverse direction. So the total power at the AC side is now altogether is 4 kW. On the display at point B and point C, which is the output power at the load for this condition, is almost 2 kW, but the power at point D is at grid 4 kW. The power had transferred back to the inverter because the phase of out voltage is negative 3.61. For the third condition, the question states the power transfer from the DC side to the load is 2 kW until the switch STS is connected, where now the power transfer of 2 kW to the three-phase load will almost come from three-phase grid voltages, which means the power is coming from the grid. So for the calculation part, for the total impedance we obtain as 0.05 plus imaginary part 1.968. For the C value we obtain 1.969 and the theta R we obtain is 88.545. So the V peak we obtain is 204.13 watt and the high phase is equals to 0. So the VA prime we obtain is 204.13 and the M value we obtain is 0.81652 and the delta is 0. So after the simulation, if we notice the waveform of the voltage across point A, B, C and D, they are same and there is no power losses. But at the current of each point there is difference. This is because the current graph is in phase because it flows from inverter to load and to the grid. When the grid switch, which is the STS switch, is turned on, the graph changes as the current flowing in a reverse direction due to current flowing from the grid to the load and to the inverter. If we see the ID graph, we can notice that the outpace graph is caused by the reverse direction of the current, which if we notice the V on versus VD graph, it is proven that the current flowing in the diagram circuit is outpace, where the voltage is at the positive region and the current is at the negative region. On the other hand, if we notice the voltage and load across the loads graph, we can notice that the current is the same as phase current that we had calculated, where the phase current is equal to 6.5332 ampere. The current is not equal to 0 because the output power at the load in this condition is 2 kilowatt. So when the switch is connected to the power, it has transferred 2 kilowatt from the grid to the three-phase load. But there is no output power at the inverter because it only transferred to the load. On the simulation part, the output at point B is 158.27 watt. Even it has some power at point B, but it still has very small current to flow throughout the inverter because the current will flow to the LCL filter as well. At point D, the output power is 2021.55 watt, which is almost to 2 kilowatt. So that's all from me. Thank you.